Hello and Assalamualaikum to Sir Amir Nazaruddin. My name is Amir Shahril bin Ismail from Group EC 1102F, and today in this video, me and my members would like to talk about Rebound Hardness test experiment. Our objective for this experiment is to determine the uniaxial compressive strength of rock indirectly and quickly, both in the field and in the laboratory. Apparatus that we need is rebound hammer, which consists of a steel hammer and a plot of compressive strength versus rebound hammer reading. We also need rock specimen in this experiment. First of all, I want to explain a little bit about the apparatus that we use, that is Smith hammer. A Smith hammer, also known as a Swiss hammer or a rebound hammer, is a device to measure the elastic properties or strength of concrete or rock. It was invented by Ernst Smith.
Okay, thank you, Shadil, for your explanation. Hello, my name is Nicholas. Now we already know what is Smith hammer. Now let's continue to how to use the Smith hammer. First, the sample to be tested can be in form of rock, mass, or rock material. For sample in the form of rock material, it can be either in regular or irregular lump. When possible, use larger piece of rock for the Smith hardness test. The hammer pan is mounted toward the face of rock and it perfectly near to vertical. Before taking the reading, the test surface shall be smooth and flat over the area covered by the plunger. Third, if any slanting reading taking, the angle should be recorded as alpha, and correction of reading should be made immediately. Number 4. Hammer is mounted to the test surface and pressure is applied on the hammer. The button on its side is pressed to retain the reading R. Number 5. The correct plot of compressive strength versus hammer reading is selected and the reading for compressive strength correspond to the hammer reading is taken. Number 6. The test is repeated for several times on sample and the average of compressive strength is calculated. Example of data. As you can see, for the sample of rock A, the first reading is 32.5, the second reading is 35.0, the third reading is 33.0, and the average is 33.5. As you can see, the rock B, the first reading is 17.5, the second reading is 17.0, the third reading is 18.5, and the average is 17.67. That's all from me. Thank you. Now let's proceed to our next speaker.
So hi, my name is Jason Esley. For my part, I'm going to explain a sample for calculation and determining the weathering rate. So here is the data of sample of the rock. We have two types of rock, which is rock A and rock B. So we take 3 times of reading to make it more accurate for the calculation. And then we count the average. Average is we sum up all of the 3 readings and then divide by 3. So here is the compressive strength of rock. This is the formula which is given in the lab report, and then the formula is log 10 JCS equal to 0.00088 times Y times R plus 1.01. Y is the weight of the rock, and then R is average. So log 10 we move to the other side, so it will be the power of this 10. So rock A rock A we substitute in the value, the weight of the rock 26, then the average is 33.5. We get 59.77 MPa, and then rock B is the weight of the rock B is 22, and then the average is 17.67, then we get 22.50. So here's the composite strength range, which is 1 until 10 is fresh concrete, 10 until 70 is normal concrete, and 70 until 100 is high strength concrete, and above 100 is ultra high performance concrete. So this is the weathering grade, and then our weathering grade is around 10 until 17, which is normal concrete for the range. Okay, thank you. That's all from us about this lab. Rebound Hardness test.